Hi, I'm always your teacher, Mr. Doka. Welcome to the topic function. Outside the realm of mathematics, the word function simply refers to what something does. But in mathematics, the word function has more specific meaning. In mathematics, a function is basically something that relates or connects one set to another set in a particular way. A set is just a group or collection of things. Often, it is a collection of numbers, but it doesn't have to be. A set could be a collection of other things like letters, names, or just about anything. A function is a relation between a set of input and a set of permissible output with the property that each input is related exactly to one output. Let A and B be any two non-empty sets. Mapping from A to B will be a function only when every element in set A has one end, only one image in set B. A condition for a function: set A and set B should be non-empty. In a function, a particular input is given to set to get a particular output. So a function f of A implies B denotes that f is a function from A to B, where A is a domain and B is called the codomain, or if there is no other to be mapped upon, it is called the range. For an element A which belongs to the set A unique element B belonging to the set B is there such that both A and B are all elements of the function. The unique element B to which f relates A is denoted by f of A and is called f of A, or the value of f at A, or the image under f. The range of f, image of A under f, it is also called the set of all values of f of s taken together. Now, for a function to exist, it must pass the vertical line test. What is vertical line test? Vertical line test is used to determine whether a curve is a function or not. If any curve cuts a vertical line test at more than one point, then the curve is not a function. You have experienced with functions like lines, straight lines, y equal to ms plus b, and parabolas are both functions because they pass the vertical line test. Representation of functions. Functions are generally represented as f of s. Let f of s be equal to s cubed is an example of a function. Function can also be represented by g of, h of, etc. Function notation is more clear than a standard equation. Example: y equal to 2x minus 5. Because after you substitute a value of s, you have y equal to something, and you can't see the original value of x. Function notation replaces the y with an f and adds a bracket beside it, which is f of. What goes in the bracket is the value of x that gets substituted in. The plain formula is f of s equal to 2x minus 5. If you want x to be 6, you write f of 6 equal to 2 into 6 minus 5. The answer would be f of 6 equal to 7. Functions work like formulas. To set the framework and plug in specific numbers later. F, G, and H are most common letters used in representing functions. You can also use letters that make sense in the question, e.g., area of a circle would change from A to A of R. That means A of 6 will stand for the area of a circle whose radius is 6, and plugging in 6 will get you the answer. Steps for solving functions. Let's take a look at this question. Find the output of a function g of t, which is equal to 6t squared plus 5 at t equal to 0 and at t equal to 2. Now, how do we solve? The given function is g of t equal to 6t squared plus 5. At t equal to 0, we have g of 0 equal to 6 into 0 squared plus 5. G of 0 becomes 5. At t equal to 2, we have g of 2 equal to 6 into 2 squared plus 5. We have g of 2 equal to 29. You can also represent functions as mapping diagrams, circles with numbers connected by arrows, and by list. Point x, y inside curly bracket. Example 0, 5, 2, 29. In order to be a function, each value of s can only be associated with a single value of y. So a mapping diagram where an x value has 2 arrows coming out of it, or a list of points with 2 different coordinates with the same x value, would not be a function. For example, the mapping we have below. Whereas one mapping is a function, the other is not a function. To tell from a graph if something is a function, imagine a vertical line passing through different points on the graph. The vertical line test. Everywhere on the graph, the line can only touch a single point. Remember, all functions are called relations, but not all relations are functions. In short, all relations which passes the vertical line test are referred to as functions.